OK, continuous integration and continuous deployment. Continuous integration you've basically all been using, because hopefully by now it is all properly set up that every time you push new commits back to GitHub, you get your automatic Travis CI test run on all of that new stuff. Not sure how many of you have moved to continuous deployment. And the extreme version of continuous deployment is you can actually set it up so that every time you push and Travis runs and everything passes, you could have it automatically then also deploy to Heroku without you doing it manually. Depends on how lucky you're feeling that day. But the big message is that the idea of continuous deployment is a relatively new idea. Windows 95, I know it's like before a lot of your time, but when Windows 95 launched, like they licensed the tune Start Me Up from the Rolling Stones so that they could play it at the Windows launch celebration. They paid to have the Empire State Building in New York light up at the top with the Windows colors. I mean, it was a release. It was like the turn of the millennium or something. Releases today are almost a non-event. As of late 2011, when I heard a really interesting talk from the then director of engineering at Facebook, he said it was not unusual to push the master branch once a week, and they were trying to move towards more like once a day. I don't know if anybody has interned or worked at Facebook recently and is allowed to say how often they're pushing new features to production. I realize they have other concerns going on right now. But at Amazon, AWS and the Amazon.com site are usually deploying several times a week. And a lot of the times, as an end user, you might not even see the effects of some of those deploys. And we'll talk about some of the reasons that might be true. Stack Overflow, heard a great talk from Jeff Atwood about this. They do multiple deploys per day. So if they're doing multiple deploys per day, what can you conclude about that? First of all, deployment has to be automatic. If deploying is anything more than pushing a button or typing a command line, it's not reasonable to do it several times a day. Second, any individual deploy doesn't have a lot of changes in it. It's probably changing a relatively small amount of stuff. What would be the motivation? If you've got, if you're going to do 8 or 10 deploys per day, what would be the motivation for doing that as opposed to like waiting until the end of the day and batching all those changes together into a single deploy? Why do a lot of people consider that it is actually less risky to do a lot of little deploys instead of like one major one per day if you can get away with it? Yeah. If you break something, right? The less you changed, the less you're likely to break something. And if you do break it, you know where the break is. It's the same as the motivation for doing TDD and doing frequent commits. If you're doing TDD and your tests are running and you add like 6 more lines of code and now something fails, you know the problem is in those 6 lines. If you're deploying and each individual deploy only has a few dozen new lines of code in it, then if you break something, you know right away where you broke it and you can roll back. So it's the same idea as behavior-driven design. The more you talk to the customer, the more you cross-check your assumptions, the less time you'll waste when something actually does go wrong. GitHub does tens of deploys per day. That's from Zach Holman, who until recently ran engineering there. And the rationale is exactly what was just said, which is how many engineer hours have been invested in the product since the last deploy? Because that number of engineer hours is proportional to the likelihood of something having gone wrong, right? Of introducing something that you did not expect. So just like development and just like doing features, the ideal deployment scenario is one where it's such a non-event that you're comfortable doing it all the time. And as I said, in fact, you can configure Heroku and GitHub to work together so that once your CI passes, you can automatically have it deploy from that branch into your staging environment. So to have a successful deployment pipeline, what do you have to have? First of all, you have to have automation. It should really be the case that it takes a single command line to do whatever deployment means for you. And by the way, that's not just git push Heroku master or whatever. Part of it is also the implicit discipline that it is always safe to say git push Heroku master. That in fact, if something has moved onto the head of master, as far as everybody in the team is concerned, it is safe to deploy that thing to production. So it's not just the deployment part itself, it's the discipline you're following about what assumptions you can make about your product. Heroku is really good as far as the mechanical part, because literally it's just like pushing, as you know, to a Git repo causes the deployment to just happen. But if you're not using platform as a service, there's a whole menagerie of tools out there that allow you to manually create scripts and config files to do what Heroku basically does for you. And continuous integration, which all of you pretty much have already been doing. Basically, you're always doing test runs. You're certainly doing them before the decision is made that the branch is safe to fold into master. If you're doing frequent push-ins and frequent check-ins, then you're doing frequent continuous integration. So again, if you break something, you'll know pretty quickly what broke. And a strategy is to integrate CI with GitHub, which is the steps that we have tried to make work for all of you, so that every time you do a push, you get an automatic CI run. Reasons to use CI, differences between development and production. We've sort of said that before, but if your production environment, you can run tests in CI that are too expensive to run in your development environment. And you can run staging tests as well that require pushing a separate staging server out. Most of your projects are sort of not big enough to make that additional hassle worthwhile. But for example, in one of the apps that I maintain, besides the production server, I have a separate staging server where certain additional tests get run that are not part of the test suite. Cross-browser testing. There are now facilities to, if you have a really JavaScript-intensive app, you can test it with all kinds of different browsers and make sure you haven't done something that breaks them. Testing the integration with other services when the remote services act wonky. So having a staging server that actually realistically tests remote integration. So instead of stubbing out, let's say, the calls to Stripe, you're actually calling Stripe, but you're calling their sandbox server. Something that is not really practical to do from your development environment all the time, but is reasonable in a staging CI. If you want to run, simulate doing attacks against your code, that's something that, again, you wouldn't want to do on your local machine. Stress testing, trying to sort of hammer an app with a lot of traffic. Again, something you could set up in an external environment, but is not really straightforward to emulate on your own. One example of this, Salesforce, which is the original software as a service, has hundreds of thousands of tests that are not only automatically run during CI, but they automatically open and assign a person to a bug report if one of those tests fails. So the more automation in that workflow, the better. And then continuous deployment, basically, as I said, you can actually auto-integrate so that every time you do a push and it passes CI, you can have it deploy automatically. So in some sense, you don't have to do any extra work to make sure that the most recent version is always running on Heroku. And the question is, if this is what releases are like now, does this mean that the concept of a release has no meaning anymore? Not necessarily. There are customer visible milestones where you say, hey, on this day, we're going to provide you with features A, B, and C. And maybe those features actually make sense to deliver together for whatever reason. So even if feature A is already present in the production environment, maybe the user interface to allow the user to get to feature A has not been deployed yet. So you can have code in production that is not really active, but at least you know that when it's under normal operation, it hasn't broken anything. One way to do this is that if you have a particular release that makes a set of features available to the user, you can choose to tag it so that when you're talking to your users, you can refer to which release they're using. Android does this with things like Marshmallow and Ice Cream Cone and stuff like that. Or you can just use the unwieldy git commit ID to identify a release. But basically, the idea is you still have the concept of telling the customer, hey, this is going to go live at a certain point. That doesn't mean that you have not been deploying up to that point. It just means that's the point at which the feature becomes ready for the customer to use and possibly available through the UI. But in the meantime, code related to that feature could still be in the production build. It's just not getting exercised yet. But at least you know that it isn't breaking anything else. OK, well, I hope you're excited because finally, it's time for your team to code. Well, code and test, of course. So we're going to talk about how an agile team functions when they're sort of in their steady state mode of getting work done, coordinating with each other, getting that work into the main code tree. And this whole workflow kind of goes into the general name of continuous integration, or CI, because each team member is continuously integrating their most recent code with the mainline code branch that represents the deliverable product. So at this point, we're going to assume that this is where your team is at. First of all, that you have prioritized and assigned points to the stories that you're going to work on during this iteration. That's what happened in the iteration planning meeting. So I've got some stories here. I have sorted them in the order of importance with the most important ones at the top. I've estimated the number of points each one is worth. And you can see that they're all in the unstarted state. If I were to click the start button, that would be me claiming a story and saying, I'm going to start working on this story. Second, your team has a shared GitHub repo. It doesn't matter who on the team owns it, but everybody on the team has the ability to access that repo, and in particular to do pushes against that repo. Third, that repo is probably linked to a continuous integration or CI service, such as Travis. Now, by the way, I recognize this is confusing. Travis and other services that run your tests for you are called CI services, but we're saying that this whole process of integrating your work on an ongoing basis is called CI. Both are true. Live with the difference. Sorry, folks. Optionally, you might be fancy and have a staging server. That's a server where you can push a copy of the latest features in the app and have the customer play around with them before you actually put those features into the production server that the customer uses. So don't worry if you don't have that, but for completeness, we're going to assume that you have a staging server that is separate from production. And you can read more about staging servers and how to work with them if you read the more detailed version in the book that covers this same material. So we're now ready to assign stories to developers. And by the way, whenever I say developer from now on, it could be a pair if you're doing pair programming, which we highly recommend. Doesn't matter. Now this looks like a busy diagram, but don't worry, we're going to go through it step by step. And in this diagram, we see two different copies of the repo. There's the shared team repo called the origin. That's the horizontal line across the middle. And there's your developer copy, your local repo, which is probably a clone of the origin repo. That's the lower horizontal gray line. And like all workflows, the first thing you do before you start making any changes is you need to make sure you've got the most up-to-date copy of everything that's in the team's shared repo. Everybody should be periodically syncing to make sure they start from a shared state. Which means the very first step in our workflow is to do a git pull or a git fetch to make sure you've got the most up-to-date copy of what everybody else has seen. Okay, so you're ready to start working on your story. Your partner and you are raring to go. And the first thing you do, of course, is you create a feature branch. This lets you make sure that your changes are going to be isolated and not affect the master until you've had a chance to finish and test them pretty well. So you start developing on your feature branch. As you develop, you're making frequent commits, of course, and each one of those gray circles is a commit on your feature branch. But you also have to push those commits up to the origin repo, because otherwise the rest of the team won't even see that. In fact, they won't even see that you've created a feature branch. So you're periodically pushing those commits to a branch on the origin repo that tracks your own branch. And in this example, we've set up the origin repo so that anytime anybody pushes, whether it's to master or to some other branch, it automatically kicks off a CI run, continuous integration, to run all of your tests, and you'll know immediately if you broke something. Now, of course, while you're developing the feature, you're writing tests for the feature that you're doing, but running the continuous integration on every push to the origin repo means that if you accidentally broke something far away in some other part of the app, you'll know about it really quickly. Okay, finally, you're done with your tests, you're done with your code, everything is in good shape, you've pushed the latest version of your feature branch to the origin repo, and now you're going to ask the rest of your team essentially permission to merge those changes into the master branch. So you do that by opening a pull request, and that's the little line with the circle on the end. This means I want to merge the contents of my feature branch into the master branch. What do you, the rest of my team, think about that? Have a look at my code, do a sanity check, see if it looks good to you. Now, keep in mind that the pull request is comparing the feature branch on the origin repo with the master branch on the origin repo. So the pull request is happening within that copy of the repo, but between two different branches. That's important, and we're going to come back to that later. So your team is taking a look at your code. Sure, your tests all work, but they maybe found a few places where there's a few things that are a little messy and could be cleaned up. So your team gives you the feedback. We think that you should fix up these things and then reopen your pull request. Okay, well, that discussion is really important because once code gets merged into the master branch and becomes part of the stable code base, you're kind of stuck with it forever. So it's worth taking some time for everybody who might be affected by your code to sort of sign off and say, yep, looks good to me. Okay, in this case, your team is giving you some feedback, so you go back, you make some more changes, some more commits, you push those commits to the origin repo, and this time you do a pull request again, and voila, your team has decided now you're good to go. You fixed all the issues, your pull request is accepted, and now your feature branch's code gets merged into the master branch again of the origin repo. That's great news because now you're one step closer to what you're really trying to do, which is solve the customer's problem. So typically, the next step at this point would be from the master branch of the origin repo, deploy that new merged code on a staging server. And by the way, notice that when we accepted the pull request, there was a CI run that happened there too. Because if other developers had had pull requests merged since the time you began yours, remember that what's being tested now on the master branch is not just your changes, it's your changes possibly added on to other people's changes. So doing that CI run on every push or merge is really important. Anyway, let's say things are good to go. Now you deploy on a staging server. A staging server is set up to look pretty much like production, but usually a lot smaller. Maybe it has some fake data that could even be extracted from the real data, but it's a place where it's safe for the customer to kick things around and not worry about screwing up their real app. So now the customer gets to give feedback on whether the features behave the way that the customer expected. That's the all-important customer interaction part. And again, in this example, we've chosen to show that the customer has actually made some revisions and said, actually, I think I want a minor change in how you did this feature. Okay, well, we know what to do. We go back to the workflow. We go back to our local copy of the feature branch. We do some more commits. When we're happy with our tests and our code, we once again push our feature branch up to the origin, and we reopen, or maybe a new pull request, saying, okay, here's my pull request, further revised because of the changes that the customer asked for. And at this point, the customer once again views the code on a staging server. The code is good to go. The customer leaps in joy and decides that the story is delivered. And now you can deploy that same code to production. So notice all the action here on this very last merge commit that happened on the master branch of the origin repo. It was a merge of our most recent changes. It triggered a CI run, again, to make sure that since other people have also been changing the code, our interaction between our code and their code hasn't changed anything. It was deployed to a staging server so that the customer could sort of do a final sign-off, and only then did it get deployed to the production server, the real server. And by the way, notice what else happened. Once that's happened, we want to do a pull or a fetch of the team's repo back to our own repo, because again, the latest merge contains other people's changes as well as ours. So in preparation for the next feature we're going to do a pull of that team repo. That's the basic workflow, but now I'm going to show you a variation on it that can arise if your team is not necessarily the owner of the project that you're working on. So how does this workflow fit together with pivotal tracker stories? Well, remember when we began, all of the stories were in the unstarted state, but when a developer or a pair claims a story and they create a feature branch on their local repo to work on it, that is essentially saying we have started work on the story. And in fact, you can actually encode your branch names so that they're automatically associated with the correct stories in Pivotal Tracker. The story is finished, well, in my view, the story is finished when I'm convinced that my tests and code are good enough that I'm opening a pull request. Now, of course, that pull request might not be accepted right away. I might still have to make other changes. So depending on your team's practices, you might decide that you don't really mark the story as finished until the pull request has been accepted and merged into master. Whichever one you choose is up to you. Just make sure everybody agrees on what it is. But at that point, the story is finished. It's not yet delivered, though, because until the customer can see it and give comments on it, we can't say we've delivered functionality. So I like to say that the story is delivered when we deploy that new code into a staging server and the customer has the opportunity to interact with it. And of course, once the customer is satisfied, maybe after another round of pull requests, and the code is ready to be deployed to production, that's when I say the story is accepted. And once again, your team might prefer to reserve accepted to mean that the story is actually deployed on the production server as opposed to ready to be deployed onto the production server. Really, all that matters is that your team agrees on what the correct meanings are. There's one variation I want to show you on this workflow, and this variation occurs when the team working on the app doesn't necessarily own the app. So, for example, if you're working as a sub-team on an app that's owned by another organization, that organization's, let's call it the golden repo, I guess, where the app originally lives, is shown as the topmost of the horizontal lines on the screen now. And we're going to call that the upstream repo, because if your team doesn't own the app, you don't necessarily have push access on that repo. So the only variations to the workflow are these. First of all, in the beginning, you have to create a fork of that repo. You're not going to clone it, and we're going to talk about why in just a moment. But your team can create a fork of the original repo, and on that fork, your team can have all of the push permissions that it needs. You're going to go through the exact same workflow that we just described, except when the feature is ready to be officially and finally merged into the mainline code and deployed in production, instead of deploying it to the production server directly, well, you probably don't control that server if your team doesn't own the original app. So instead, you're going to do a pull request from your final commit that's merged to your team's origin repo up to the repo owned by whoever owns the app. And the same essential protocol is followed, where they're going to review your code changes. They may ask you to revise and reopen, but at some point, your pull request will hopefully be accepted. It will be merged into their master branch, and then they will deploy from their master branch to the production server, which they control. And finally, you now have to make sure that just as when you were developing on your own, you needed to periodically resync your team's shared repo back to yours, well, in this case, the upstream repo may have additional changes from other subteams, so you have to sync those back as well. And because of the way GitHub works, the machinery for doing that is a little bit weird. You actually have to pull those changes down to one of the clones, and then from the clone, push the changes up to your team's origin repo. You can read more details about that in the more detailed description in the textbook, which also contains some pointers to excellent tutorials and articles on GitHub itself about how to do these operations. But keep in mind that when you're working in this fork and pull model and there's an upstream repo that is where the app officially lives, it is because you fork that repo that you're able to do pull requests against it. So that's the only variation when there's an upstream repo. You begin by forking that repo to have your own team's repo, and when you're done, you're going to do a pull request back to the master branch of the upstream repo and get your changes pulled in that way. Now, in the workflow that we saw, there are two places where there are sort of loops, meaning that even though you did a pull request, your team might not accept it the first time. Or even though you deployed to staging, the customer might not be happy with the story the first time. Some amount of that is just a byproduct of an agile workflow in which you're trying to keep communication constant between the customer and the team, right? Part of the whole point of agile is you can make changes while it's still less expensive to do so. But there are things you can do and practices you can follow to minimize how often that happens and sets you back. We already said this when we talked about stories and points, but man, small stories are really your friend. A small story means that your code changes are going to be small, so your branches are going to be really simple. That means they can be short-lived because it doesn't take a very long time for your team to review your pull requests, and you'll almost never have to rebase. So even more importantly now, short stories are really good. Respecting your team's own work. If you spent time in the iteration planning meeting, it was to prioritize and assign points to those stories. Respect that priority because whatever you were thinking then, it's no less valid now. So as you start working on your stories, pull off whatever is at the top of that priority queue and work on that one next, not the one you think might be most fun. And work on one story at a time. If your stories are pretty short, then you should be able to completely finish one story, put it to bed, pull request it before you start another story and have a proliferation of feature branches, and you're not really sure which branches have been merged back and which ones have not. Now, of course, if you're working on a story, you might unexpectedly discover that further progress is blocked until some other story is done, maybe even a story that someone else is working on. So when we talked about how you prioritize stories, you have to account for the fact that sometimes one story may block another, and sometimes you don't find that out until you actually start working on the story. You do the best you can, but in general, try to stick to one story at a time and have it completely cleaned up before you move on to another story and create more branches. And work at a sustainable pace. Remember that velocity is supposed to be a rough measure of how much work you're getting done each iteration, but if you deliver all of those points at the end of the iteration, then you're negating an important advantage of this agile workflow, which is having the team constantly able to comment on each other's work and sort of stay up to date with what's happening in the app. So delivering a small amount per day, which is another reason that one-point stories are great, you can knock them out quickly, and having your team review it as soon as possible, having the customer give feedback as soon as possible. Working on short stories one at a time will give you a sustainable pace, And over time, that's going to be much more important than getting the total number of points crammed in right at the end of the iteration, just to say that you were able to do it.